Good morning, all of you. So, in last class, we have learned special cases of adiabatic process. Yes, that adiabatic process was going on. So, let's move ahead. And now, today, that is indicator diagram. What is the next part? Indicator diagram for this adiabatic process. Indicator diagram means what? PV curve, hai na? Yes, that is what PV curve is. So, let's draw it. This is pressure and this is volume. On y-axis, you are having pressure. On x-axis, you are having volume. Okay. So in adiabatic process, what is the constant? You know, in adiabatic process, PV power gamma is equal to constant. Yes or not? Already we have learned. This is what Poisson's equation. Now, by differentiating this equation, what we are getting here, d dt of PV power gamma is equal to d dt of this constant. D dt of this constant. So this is equal to 0. So here you have to use UV rule. So what we are getting? dP so dP phi power gamma plus P gamma into phi power gamma minus 1 into dP is equal to 0. I am transferring this term this side. So dP phi power gamma is equal to minus P gamma phi power gamma minus 1 into dV. Now this dV I am transferring here and this phi power gamma this side. So dP by dV is equal to minus P gamma phi power gamma minus 1 divided by phi power gamma. So dP by dV is equal to minus P gamma. So this is V power gamma minus 1 divided by V power gamma. Right? So now I'm transferring this up. So what I'm getting? Minus P gamma. This is V power gamma minus 1. And this one I'm writing up. So V power minus gamma. So can I write like this now? Minus P gamma V power gamma into V power minus 1 into V power minus gamma. Check it once. What I did, I have differentiated, then this part, just I have taken this gamma up, so it became minus, and this a power m minus n, a power m into a power minus n. So just cancel this and this I'm cancelling. And what I'm getting now, that is equal to minus P gamma v power minus 1. Let's take it back. So minus p by v into gamma is equal to dp by dv. Therefore, dp by dv is equal to minus p by v into gamma. You can keep it in box. This is what dp by dv from this indicator diagram, right? So here also, if you want to note down first, okay? This is what slope dp by dv. We got like this. Check it once. And therefore, here I am writing slope of adiabatic curve, that is tan of theta is equal to dp by dv, and therefore tan of theta is equal to minus p by v into gamma. Is that clear? This is what slope you can write below the graph. This just formula you keep it in mind, right? Let's move ahead. Next. Now, specific heat in adiabatic process. What is the specific heat in adiabatic process? Let's see. Specific heat in adiabatic process. So as you know, specific heat formula is what? S is equal to Q by M into delta T. So Q is equal to what here? 0. Therefore, S is equal to what? 0. Specific heat capacity is what? 0. In which this, isn't it, right? Next one, adiabatic elasticity. The same pattern for every process. If you will go back and revise once, you will get to know adiabatic elasticity. Adiabatic elasticity. In this, you are having this E phi is equal to gamma times P. Okay. E phi is what? Gamma times P. You can keep it in mind. This I think in isothermal you are getting only pressure, but here it is not like that. Just E phi is equal to gamma. Just keep it in mind, and you can keep it in box also. Okay. Next one, work done in adiabatic process, which is very important. So let's take next page and see here. Work done in adiabatic process. Work done in adiabatic process. Now, see, W is equal to integration of P dV from Phi to Pf. Phi to Pf. Now, in this process, what is the case? PV is equal to, or PV power gamma is equal to constant. Let us suppose K. So therefore, if I want P value, then it is what? K by Phi power gamma. K by Phi power gamma. So let's substitute here. So I'm substituting here in this place of P. So what I'm getting? W is equal to integration of Phi to Vf at the place of P, K by Phi power gamma into dV is equal to K by Phi power gamma into dV is equal to. Now here this constant is equal to what? So I'm writing here in this case what we are getting. So what I did here, K by P power gamma into dV I have taken, and now if we will solve this, what we are getting? Pi Vi minus Pf Vf divided by gamma minus 1, and that is equal to nr Ti minus Tf divided by gamma minus 1. This is what work done in adiabatic process. Okay, right? You can keep it in a box. This is what work done in a adiabatic process. I want to give you one table which is very important. We can say comparisons. Okay, how we can compare these two processes. So let's make one table, isothermal and adiabatic change. I'm making like this table, and let's have only two columns. Big column I'm taking. What is that? Isothermal. And one more we will make, that is serial number. So here it is serial number. This one is isothermal. This is isothermal. And here it is adiabatic. What is here? Adiabatic. Okay. So let's see here. In this isothermal, what is remains constant? Temperature. Temperature remains constant. So what is your delta T is equal to? Delta T is equal to 0. Here what is the case? No exchange of heat. No exchange of heat. So here delta Q is equal to 0. Keep it in mind, different, what you can say? You just compare and keep it in mind so that it will be very easy for you. I am giving you point wise, not an issue. This is point number 1. This is point number 2 now. Let's see what is the point number 2. System is thermally conducting to the surroundings. Conducting to the surroundings. Means what? The system and surrounding, there is a heat exchange, yes or not? Means conduction, there is a conduction. In this case, you see, system is thermally insulated. System is thermally insulated from the surroundings. Right? Next one, point number 3, you see, the process takes place slowly. Which one? This one. The process takes place slowly. Which one? This isothermal. This one, you know how it is taking place. It is sudden, how it is sudden. Just shall I write here sudden process, or the process takes place quickly? You can write in whole sentence also. The process takes place quickly. Which one? This adiabatic. This is your point number 3 finished. Okay, next one, fourth number point. Internal energy, that is delta U is equal to 0. What is 0? Delta U is equal to 0. And here delta U is not equal to 0. This is your fourth point. Easy. Is it easy? Yes, it is very easy. Why internal energy is 0? Because here temperature is constant. Here there is not constant temperature. There delta Q is 0. Next one, fifth point. Specific heat capacity is infinity. Here specific heat capacity is equal to 0. Yes or not? Specific heat capacity is what? Infinity. Yes is what? Specific heat. Keep it in mind. Specific heat is infinity. Specific heat is 0. Next one. Equation of state क्या है? Equation of state. Equation of state, in this process you are getting PV is equal to constant. And here what is the equation of state? PV power gamma is equal to constant. PV power gamma is equal to constant, right? Next one, seventh one, slope. In this slope, if you will see, dp by dv is equal to minus of p by v. And here if you will see slope, dp by dv is equal to minus gamma p by v. Gamma times you are getting. Next point, isothermal elasticity. Eighth one, isothermal elasticity. If you will keep this table only in mind, enough. So what is that? E theta is equal to P, and here E theta is equal to what? Gamma times P. And last point, what is that last point? C. Which one? Work done, isn't it? Right? Last one is work done. In this case, that is isothermal. Is I indicates isothermal. Okay. nRT log to the base E. Phi F means final by P initial. Or that is also equal to nRT log to the base E Pi by Pf, which is what your work done. Yes, and here W in adiabatic process is what? Pi Pi minus Pf Pf divided by gamma minus 1. That is also equal to Nr Ti minus Tf divided by gamma minus 1. Okay. Just keep this table in mind, and it will be very easy for you. Okay. So let's stop here. Bye for today.